Welcome back to the science lab, or as it's now better known, my kitchen. So today's quick demonstration before I begin is simple. There are a few things I really need in my everyday life. One, money. This is a dollar coin, and Mr. Kuchikopi. He just keeps me de-stressing at my desk whenever I get angry because the homework won't upload. So these are two things I work with in everyday life. They look very different and they also behave very different. So let's look at one characteristic that is one of the main differences between these two objects. This is water. Let's see what happens when I drop this coin in. Now by Kuchikopi. Why can Kuchikopi float, but not my
coin?
Let's get into it. The reason why some objects float and others don't has to do with density, how condensed the particles of that matter are into a certain volume. So we need to know two things in order to determine their density, their mass and their volume. So let's get into that. Mass, volume, and density. What is mass? Mass is the amount of matter an object has. So some objects are small but have a lot of mass, and some objects are large but have a small amount of mass. Mass is just how much stuff they're made out of. Matter is the stuff, okay? Our unit of measurement for mass is kilograms or grams in the metric system. What do we use to measure mass? You should be able to tell me the name of this object based on our last lesson on safety and lab tools. I'm going to ask about this object tomorrow in class, so make sure you know what it's called. I'm not going to tell you right now, that'd be too easy. Remember, what is volume? So now we know what mass is, how much stuff something is made out of, you know, how much stuff is compacted into that area. Our volume is the space that it's taking up. So we have the mass and we have the volume, the size. You might think of mass as in terms of something being light or heavy. However, mass and weight are not the same thing. When you're weighing something, you're measuring a force, the force of gravity pulling it down. It does have to do with the mass, but it's not just the mass, okay? There's a gravitational component. So we'll talk about forces when we get into the physics unit. For now, all you have to remember is mass is not the same thing as weight, but they are related. So if something's very heavy, it has a lot of mass. If something is very light, then it has less mass. Volume is how much space it takes up. So for example, this is very light and it's also very small. Whereas this is also very light. They're about the same heaviness, but their volume, their size is a lot different. Our unit of measurement for volume is milliliters, usually for liquids, and centimeters cubed, usually for solids. What tools do we use to measure volume? Well, it depends. Is it a liquid? Is it a solid? Usually for liquids, we use things like graduated cylinders or test tubes, where we're able to see the milliliters that liquid occupies. Liquids are nice in the way that they mold to the shape of the container you put them in, whereas solids have a set shape and you can't mold them into something else when you put them into a graduated cylinder. It's not a measurement of how much volume there is there, because some of these solids don't have the same shape as a graduated cylinder, right? So for solids, there are two ways to calculate or measure the volume. It depends on whether they are regular shaped or irregular shaped. Regular shaped objects are things like cones and cubes and cylinders and spheres, where you can mathematically calculate the shape of the object. Then you have irregular shaped objects like a rock or a paperclip. There's no calculation for the volume of a paperclip. That's not on your formula sheets. Same thing with rocks. Each rock's slightly different. So how would you be able to calculate that? Would you have to like cut it down into different slides of rock and then add them all together? Well, there's an easier way than that, and we'll talk about it. First, let's go with the regular shaped objects because those are easy. For a regular shaped object, we use formulas and rulers. So for example, for a cube, it's length times width times height. And you probably have seen this before in elementary school or previous years of middle school. So the length, the width, and the height you measure with the ruler or a meter stick or whatever, depending on the size, right? And then you multiply all three values together. And the units would be centimeters cubed. Why? Because you have centimeters times centimeters gives you centimeters squared, times centimeters again, centimeters cubed, because you're multiplying three different measurements. And if you put in some example numbers, like in this cube on the slide that I'm showing you, it has 6, 3, and 4. Those are your three measurements, your length, your width, and your height. You multiply all of them together. 4 times 3 is 12, times 6 is 72. So the volume of this prism, because it's not a cube, it doesn't have the same size for each value, length, width, and height. So it's a prism. This prism's volume is 72 centimeters cubed. Length times width times height. There's different volume formulas for different shapes. This is the simplest formula. Prisms, length times width times height. There's, for example, spheres. Those would be 4/3 pi times r cubed, which is the radius of the sphere. But don't worry, I won't have you memorize all these volume formulas. If you need them, they would be on a formula sheet or on the question themselves, and or just give you the volume. So it should be fine. The only one you should probably remember is the volume of a prism. Length times width times height. Very simple to remember that, okay? All the different sides of the shape multiply together. Very simple. Now, what about the irregular shaped objects? Well, let me tell you a quick story time. Long time ago, in the era of the ancient Greeks and such, there used to be a very, very famous philosopher and scientist and just amazing, smart person overall, named Archimedes. This man was highly regarded as someone in the science community. In astronomy and physics, in math, he really knew his stuff. And so, one day, in his hometown, he was from Sicily, just in the vicinity of Italy. He was commissioned by the king to find out if his crown was made of solid gold. So back in the day, right, if you wanted to make something of gold, you would give the gold to the person that shapes it. And then that person made him his crown into the shape he wanted. However, he wasn't sure that all the gold that he had given him was what's on the crown. He felt something was off, but he wanted to make sure that it was made of solid gold. So there's a way to know if it's made of solid gold, to measure the density of it, because gold has a different density than silver. And something that's very common is that there would be alloys or mixes of different elements to make something less expensive. What the king thought is that he was being swindled by this man, and that he hadn't used all the gold into the crown and kept some for himself. So the idea is if he was able to calculate the density of the crown and it was the same as the amount of gold the king had given this person, then it was made of pure gold. But if the density was smaller, that means he mixed it with something else like silver, which is lighter than gold. And so it wasn't pure gold. So Archimedes started to try and figure out how to do this because crowns are not a regular shaped object. And the king had a catch. He couldn't mess with the crown. It had to remain the same way. So he couldn't chop it up and measure different parts of the crown and add it all together, right? So again, we're in this dilemma of how do I measure this volume? Because mass, you put it on the scale and you know the mass of it. But volume is a lot more tricky. So one day he was taking a bath, as in that picture, and he noticed that the amount of body that he submerged is how much water went up on the tub. So if he wasn't in the tub, the water was a certain level, and as he submerged into the tub, the water level rose. So when that happened, he ran out of it, says the legend, and ran naked through the streets and yelled, "Eureka!" which means I found it. And he realized if he submerged the crown in water and he measured the difference between the water before the crown was submerged and after, that would be the volume of the crown. And that would be able to solve his issue. And apparently, the king had been swindled. That crown was not pure gold because it was much less dense. And so now, thanks to Archimedes, we're able to calculate the volume of irregular objects, and we call this the Archimedes principle. Don't worry, you don't have to remember that it's called the Archimedes principle. Just thought you should know the background. Finding the volume of the irregular shaped object, now we know you don't use a ruler, you use water. So water is our universal liquid that we submerge things in because we know the density of water is 1. And so it's simpler to use if we had used something like oil that has a different density. So it's not going to be the same effect. So we find the volume by the water displacement method or the Archimedes principle. How much water is shifted. So if we fill a graduated cylinder with water and we read the volume of the water, and then you add the object in, the water will go up, and now you read the volume of the water again with the object in it. You subtract the end from the beginning, and that's the volume of the object. So let's do a quick example. To measure the volume of something in a graduated cylinder, again, we have water in a graduated cylinder, and we're able to measure here. It's at the 7 milliliter mark. So that's the volume of the water before. Then we put the shape into the graduated cylinder. And now we measure the water again. Remember, you have to wait until it settles down. Once the water stops moving, you measure where it's at now. And you notice that it went from 7 to 9. And so the volume of the object itself would be 9 minus 7, 2 milliliters. And that makes sense. If you are having struggles with understanding this topic, don't worry, we will review it tomorrow during class. And if you have any more questions, feel free to reach out. That's it for us today. Don't forget to answer the questions below if you are on the forms page, and if you're not, go back to the hub, click on it, answer the 2 questions below the video, and I'll see you in tomorrow's class. Bye.